Good morning, seventh grade, second science lesson today. So yesterday we learned what magnetism is. Today we are going to look at magnetic fields. So first let's start with fun facts about cows actually. I'm excited about this one. This one's kind of fun. So I'm going to read cow magnets to you guys. You probably know that cows eat grass. Did you know that they also eat metal? When cows graze, they may ingest metal objects that contain iron, such as nails, wires, and old cans. If the metal is sharp, it could pierce the cow's stomach, causing infection, illness, or even death. To ensure that the cows are safe, farmers have their cows swallow a magnet. Once inside the cow's stomach, the magnet attracts the iron in the metal that the cow eats. This keeps the metal from moving around and possibly puncturing other organs. One magnet can protect a cow for life. Okay, so let's look at these couple questions. Why is it dangerous for a cow to eat metal? And then as a farmer, what else could you do to keep metal objects from harming the cows? Okay, so think about those for a second here, and then I will give you what I came up with as the answers. Okay, why is it dangerous for a cow to eat metal? Well, because sharp metal can pierce a cow's stomach or other organs, which obviously would then kill them. And then as a farmer, what can you do? I said you can keep them away from metal objects, whether that might be cleaning up your fields or just putting them in a pasture you know is clean. That's just one option. Maybe you had something different. But when we talk about magnets, let's look at our key questions for magnetic fields today. What is a magnetic field's shape? And what is Earth's magnetic field like? Okay, just two of them again today. First of all, what is a magnetic field? The area of magnetic force around a magnet. And then magnetic field lines are lines that map out the invisible magnetic field around a magnet. So invisible lines, you can't actually see the magnetic fields, but the magnetic field lines are what would determine where the field is. So what do they look like? Magnetic field lines spread out from one pole. So if we have a magnet, I don't have one, but just pretend. So from this side of the magnet, and then they would spread out from that one pole, curve around the magnet, and return to the other pole. So if here's our magnet, you're going to go from this side to this side, okay? Where would a magnetic field be strongest? Well, let's look at it here. Sorry, actually we're going to stay on the slide. So where would a magnetic field be strongest? Well, if it's starting at one pole, going to the other, whichever pole that field starts at is going to be where the field is strongest. And then the pole that it ends at is going to be where it's weakest. Okay, so two different kinds of magnetic fields. We have a single magnetic field, which would be if we only had one magnet, and then the field would look like the magnetic field lines. So fairly easy on that one. What about a combined magnetic field? So that would be with two or more magnets. And what the magnetic field looks like depends on how the magnets are interacting. So if you have a north to north or a south to south field, those magnets are alike, so they are going to repel each other. So then the field is going to go away from them rather than to each other. But if you have a north-south field, because they are different, they are going to attract each other, and then the field will connect the two magnets, making it a stronger field. So if you have two that are the same, they're going to repel, and then the fields are going to go away from each other. But if they're the same, if they're different, they're going to attract each other, and the field will create a stronger magnetic field. So what about Earth? Earth has a magnetic field. So you know about a compass. A compass is a device that has a magnet on a needle that spins freely. So just like a bar magnet, so the magnets that you looked at yesterday, Earth has a magnetic field around it and two magnetic poles. So why does a compass work? A compass, if you didn't know, will always point north because of the magnet. So if you have a compass, it points north because Earth acts like a giant magnet, attracting the magnet in the compass. So then you have magnetic declination, which is the angle between geographic north and the north to which a compass needle points. So because the magnetic poles of Earth can move, the magnetic declination can change. So let's look at our vocabulary for today. So we have magnetic field, the area of magnetic force around a magnet. Magnetic field lines are the lines that map out the invisible magnetic field around a magnet. Sorry, that should be magnet, not magnetic. Compass, device that has a magnet on a needle that spins freely. Magnetic declination, the angle between geographic north and the north to which a compass needle points. Okay, so that is it for our lesson today. Nothing too complicated, I don't think. We are going to be looking at an IXL standard that compares magnitudes of magnetic forces. Okay, so I'm just going to go through some of these questions here with you real quick on IXL. So we're going to hit start. So we're looking at comparing magnitudes of magnetic forces. So the images below show two pairs of magnets. The magnets in different pairs do not affect each other. So we have pair 1 and pair 2. All the magnets are made of the same material. So we're thinking about the magnetic force. So what is either attracting or repelling the two magnets? So the magnetic force between the magnets in each pair. Which of the following statements are true? So if we have a north and south pole here facing each other, they are going to attract each other because they are opposites. Here we have a north and a north, so they're going to repel each other. So it's asking if the magnitude is greater in pair 1 or pair 2, or if it's the same. We're going to say pair 1, which is wrong. Let's look at why we're wrong. So we're thinking about that magnetic force. So when they attract, they pull together. When they repel, they push apart. The pushes and pulls are the magnetic force. The strength of the force is its magnitude. The greater the magnitude of the magnetic force, the more strongly the magnets attract or repel each other. You can change the magnitude by changing the distance. The magnitude of the magnetic force is greater when there is a smaller distance between the magnets. So here it's only 18.8 millimeters away. So that one is going to have the stronger one. So let's try another question. So these magnets look a little different. Okay, so they have the same distance away, but notice this magnet is way bigger. So this one is asking which magnetic force is smaller. I'm going to say pair 1. Okay, and that is correct. Okay, let's do one more. So here we have this magnet is the same size, this magnet is the same size. Which one has the lesser distance? 1.35 centimeters is less. So it's again asking which one is greater. So we're going to say pair 1, and we are correct. So I want you to just answer these questions. You're going to aim to complete both stages of the challenge. And that is your assignment for today. Have a great day. Let me know if you have questions.